So for today's lesson, we are still going to be drawing our own pictures, but we're going to be talking about things that are called angles of elevation and angles of depression. So the angle of elevation is the angle formed between the horizontal sight line and then your line of sight line when a tall object is being sighted. In other words, you've got this person that's standing here in the corner, and if a person just looks straight across, out to wherever he's focused on, he's got a horizontal line of sight. But when he looks up to an object, he's got this other line of sight in which the angle of elevation is found in between those two sight lines. Okay, so the angle of elevation, think about something going up. Angle of depression is the angle that's formed between the line of sight and the horizontal when the object beneath the viewer is sighted. So now I've got a person that's standing on top of something, or I don't know, on top of a building, on top of a diving board, something along those lines. If he looked straight across from where he was standing and then looked down at an object beneath him, the angle of depression down, angle of depression, is going to be the angle between those two particular lines. In either case, you can make a right triangle out of these particular sight lines. Okay, so you can make a right triangle, and up top it would be one of these, and then you'd have your normal right triangle. You can go for the trig because you've got that right angle here in the bottom left corner. And then you could also make a right triangle out of this particular triangle, and you'd have this triangle that's a right triangle that looks like that. One thing you have to understand is this horizontal line up top and this horizontal line on the bottom, those lines are parallel. And you've learned something about parallel lines cut by transversals, that alternate interior angles happen to be congruent. So it turns out that the angle X, the angle of depression that's out here, is really the same angle inside your triangle. It really is like the same angle of elevation, but it's not that in the beginning because it talked about the depression. So the depression angle can turn inside the triangle to be the angle of elevation, depending on how you want to work with your triangles. Okay? Let's see what we got. Draw a picture of the trig ratio, round size to the nearest tenth, angles to the nearest degree. A person at the top of a lighthouse sights a boat in the water. The angle of depression is 50 degrees. If the lighthouse is 70 feet tall, find the distance from the foot of the lighthouse to the boat. So I've got a lighthouse. So I'm going to draw some sort of lighthouse, nothing fabulous, but we've got this lighthouse that's right here. The lighthouse is in the water. Here's a boat that's in the water. Well, I can create a right triangle. Let me get, oh, we've got a person. I forgot the person. So I've got the person that's up here. So my person, when he looks straight across out into the distance, and then when he looks straight down to the boat in the water, it's right here is the angle of depression. And the angle of depression is 50 degrees. Well, it turns out that the lighthouse is 70 feet tall. I don't know if that's for me or not. The lighthouse is 70 feet tall, and they're looking to find the distance from the foot of the lighthouse to the boat. The foot of the lighthouse to the boat would be down here on the bottom. Okay, somehow this recording got paused. I paused it and then somehow it stayed paused. I don't know why. So let me explain what I did on this first problem, and then I'll redo all the other ones. We did the angle of depression, which was the 50 degrees outside, which I transferred to make it inside. And then we realized that our setup was going to be a tangent. So the tangent of 50 degrees is opposite over adjacent, and that's where we've got tangent 50 equals 70 over x. That's this piece. When you cross multiply, tan 50 times x equals 70. That's this piece. Divide both sides by tan 50, and you get 58.7 feet. Okay, let's see if we can pick it up from the next one, because again, I thought this was all being recorded and it wasn't. So here we go. A surveyor is standing 100 meters away from a 42-meter building. What's the angle of elevation from the surveyor to the top of the building? So we've got a building, which is right here. And the building and the ground should always make a right angle. A surveyor is standing 100 meters away from the building. So that means here's where the 100 feet is. And then the surveyor is looking towards the top of the building. So the surveyor is now looking up to the building, and here's where the angle of elevation is. The building itself is 42 meters tall, and the angle of elevation is what we don't know. So what's the angle of elevation? Well, here's the angle of elevation. We've got an adjacent and an opposite. It's a tan function. So we've got the tangent of x equaling opposite 42 over adjacent. Don't forget when you're finding missing angles, you're looking for the inverse tan function. So we've got this one to be x equals 23 degrees. Remember, here what you're doing in your calculator is you're doing not tan, but second tan, 42 divided by 100. Okay, let's take a look at number 3. From a point 100 feet away from a flagpole, the angle of elevation to the top of the pole is 74.2 degrees. Find the height of the flagpole. So we've got this flag pole, which is right here. From a point 100 feet or 100 meters, 100 feet away from the flagpole. So the flagpole on the ground should be making a right angle. From a point 100 feet away, the angle of elevation to the top of the pole. Well, the angle of elevation is right here, and this angle of elevation is 74.2. What's the height of the flagpole? That's our unknown. We've got opposite and adjacent, so it's a tan again. This becomes tan. 74.2 equals x over 100. When you cross multiply and round to the nearest tenth, you get 353.4. Okay, last one. Last one. So from a height of 250 feet, the angle of depression to an object on the ground is 42 degrees. Find the distance from the observer to the object on the ground. So the observer must be on top of this 250-foot thing. So we know that we've got something that's 250 feet tall, and there must be, the observer must be somewhere up top and is looking at an object on the ground. Well, the building or this whatever it is has to make a right angle with the ground. It's an angle of depression. So what happens is we've got this sight line that's going across, but then we have the sight line that's going down. And the angle of depression happens to be up here. It's outside of the triangle. It wants to know the distance from the observer to the object. So the distance from the observer to the object happens to be along this hypotenuse here. So we're trying to find x. Whoopsie. So we are trying here to find x. So we've got this triangle, and I'm not going to flip it upside down. I'm going to keep it right side up. I'm going to use a triangle right here. But remember, we said that an angle of depression is the same measure as the angle of elevation, but you have to show the depression angle outside the triangle if you're going to flip it in. And now what happens here is we've got our angle measure. We've got the hypotenuse. We've got the opposite. And we're dealing with sine. So the sine of 42 equals the opposite over the hypotenuse, 250 over x. Cross multiply. Sine 42x equals 250. To get x alone, divide out both sides by sine 42. And then x, because we're dealing with the missing side, is 373.6 feet. Okay, so that should take care of it. Good luck with the homework.